In this exercise, we pick up where we left off in class today. So we're going to have quantity on the horizontal axis, and we're going to draw a market demand into the picture because the monopolist's demand, that is the demand for the monopolist product, is the market demand. So it's the typical standard downsloping demand curve. We discovered today that the marginal revenue curve is going to be steeper. In fact, if I had drawn this to scale, it would have been exactly twice as steep as the demand. So it'll look something like this. And we had an argument for why it was downsloping. That is to say, in order to sell another unit of product, we have to lower the price, and so it stands to reason that we get less revenue each time we lower the price. And this gap between the demand and the marginal revenue is due to the fact that when a monopolist wants to sell an additional unit, they lower the price during that time period on all units sold. The first one, the second one, the third one, up to the nth unit that actually gets sold. So we had an argument then for why the extra revenue you would get from selling another unit would be less than the actual price you were charging for it. That's a tricky argument, so I want you to think hard about it and try to convince yourself of that graphically and in numbers if need be. What we want to do now is superimpose our cost curves into the picture. So I have a marginal cost, and I'm going to draw an average cost curve. And the only thing that we know for sure is that the marginal must cut the average at the minimum point on the average, same argument as we saw earlier, and that if the marginal is below the average is going to get pulled down. If the marginal is above the average is going to get pulled up. So the question now is, how much output is this firm going to produce? And the answer is, it's going to produce where MR equals MC. The very same argument that we made for why marginal revenue must be equal to marginal cost in competition in order to maximize profits holds for the monopoly also. If marginal revenue were bigger, there'd be an opportunity to expand profits by producing more. If marginal cost were bigger, there'd be an opportunity to expand profits by producing less. So it must be the case that the monopolist is maximizing profits where MR equals MC. So in this case, that's right here, all right? And that's what's going to determine the monopoly profit maximizing level of output. What's different, however, is that the monopolist is going to charge the highest price that they can in order to sell QM units of output, and that's way up on the demand curve. So the monopolist sells at PM the quantity QM, and that will be maximizing its profits. Okay? So next, now that we've identified output and we've identified price, we can calculate total revenue, and that's going to be P times Q, so it's that box right there. We can now remember that Q times ATC equals TC, and so we can follow our Q up to the ATC curve. That's right here. There's ATCM, and this is going to give us the total cost box, and therefore this area is going to be the profits for the monopolist. Unlike competition, this monopolist is earning a profit, and there will be no entry immediately to compete that profit away. Why? Because of barriers to entry. So this profit-making monopolist can continue to make these profits ad infinitum or until somebody figures out how to overcome the barriers to entry.